Hi guys, today we are going to discuss about some MEP interview questions and answers. These are the questions regularly asking in MEP construction engineering. My name is Shibin. I have an experience around 13 years in Gulf as a design part, construction part, everything. So our first question, I prepared some question and answers. First question is, which standard is using HVAC? There is mostly two standards are using, ASHRAE and SMAGNA. There is, the booklets are available, you can purchase it and you can, study it. What is the purpose of three-way valve and two-way valve? These two valves, where it is located? In FCU and AHU, fan coil unit and air handling unit. Two-way valve is using if HVAC system is running in VFD, variable frequency drive. And if it is in constant speed, we will use three-way valve. That's only difference. The third thing is that what is HVAC? A heating, ventilation, air conditioning system. That you know already, I know. How to maintain pressure in HVAC piping system? It's very important question because due to condensation, evaporation, the pressure will decrease. The pressure also will vary. It depends upon the piping system. 3 bar, 3.5, 4, 4.5. In this range, you will get always the reading. For keeping the pressure in the chilled water system, chilled water pressurization unit, it's a special unit actually. That unit can sense the pressure inside there's a sensor is there. That sensor sensor is connected to the BMS as well as there is a control panel is there. The control panel is connected to a booster system, booster pump system. It's automatically, that booster pump is already connected to the chill water pipe. And there is an external water tank is there. So when the pressure is, the water content is, or pressure is decreasing, automatically the pump system will charge because it will sense and it will feed the, extra water to the chilled water system. So it will always keep in the standard pressure. Fifth question, can you please explain what is HVAC unit insulation? Of course, HVAC means either heat or cold. It is transferring to a media or duct or pipe. It should be insulated, of course, because, condensation and evaporation we need to stop. Unless otherwise we are losing a lot of energy. Because when the cold line is passing, like for example, 6 degrees Celsius temperature, and the atmospheric temperature is 25, 30, sometimes it's 40, 45, like this. So of course you lose a lot of, this insulation is making a, protection from the atmospheric conditions. The thickness of insulation, the density of insulation is all depends upon the calculation. What is the temperature is going on, what is outside temperature, what is inside temperature, and what is the thickness of the pipe. And, a lot of things are there. There is a table is there, of course. And what is the difference between FCU and AHU? It's a very important question. FCU means fan coil unit. Also, fan coil unit is basically located in unoccupied areas, like, in the corridor or in the rooms or somewhere. Of course, it is an occupied area. Occupied area means the people, they can walk and they can travel, such kind of area. And FCU is basically, to cool a specific area, not for a wide area. Because FCU having a limitations up to normally 2.5 ton, 3 ton FCU is issuing, but FCU is available up to 5 ton in carrier. But regularly that all, maybe belt drive, it will make a lot of noise. That's the reason 2.5, 3 ton normally is using. HU means it is located in the plant room. HU having a, it's very big capacity, 80,000 CFM, 100,000 CFM, like this very huge size of AHUs, we can customize the HU as per the room heat load calculation. Like, AHU, there is a big separate fan coil room is there, filter unit is there, and there is, a lot of systems are there. Pumps are there, like blower fan is there. Such kind of things are there. So AHU is using basically for, large, heavy. And this AHU is connected to the, for example, your open area, very big hall. Somewhere we need to supply the cold air. So AHU is more better. Like, for example, railway stations, airports, and for example, a drum jet diffuser. You see some big hall in the airports, the air is pushing to the long distance. Such drum jet diffusers, everything is connected through. Number 7, how does a chilled water system operate? It's a very important question. The heart of a chilled water system is chillers. Chiller, there is a chiller is there. A lot of companies are making chillers. Even Carrier they are making, and the chillers. The one end of chiller is connected to the cooling tower, and another end of chiller is connected through heat exchanger. Again, your chilled water pump room system. You got it, my point. So this and the chiller temperature and the speed, the flow of water, everything depends upon the building management system. Now, before it was all static system, but nowadays VFD, variable frequency drive systems are there, BMS systems are there, building management system. This, for example, the occupancy sensors are there. Depends upon the occupancy, the people. For example, you are making HVAC for a big airport, and the rush is too much, and so many people are standing. Of course, there is a heat is more. So in that situation, there is occupancy sensor are there. It will sense the people, and of course, it will sense the heat. And depends upon that, the BMS system will give the command to the chilled water system and the chillers. So they will increase, it will increase the efficiency. If it is not required, it will decrease the efficiency so that they can save the, electricity, the power, like that. This is very important question, number 8. In airports and some elsewhere. In airports, Glycol systems are commonly used. Can you explain how it operates and how it works? Normal chill water system, that chemicals cannot provide 0 degrees Celsius air. You know where it is using? This is a separate line system. Glycol pump room also is separate, and chemical also is separate. When the aircraft are, standing in the rotundas or your bridge, there is a yellow color house connecting from the bottom of the aircraft. This is Glycol connection, because that, air conditioning system is separately, the Glycol air handling unit is there, Glycol. That air handling unit, there is 2-3 coils are there. The first coil, it takes atmospheric, there is one AHU is there, fresh air AHU. From the fresh air AHU, 20-22 degrees Celsius temperature. If, for example, your outdoor temperature is like 40, 48 or 50, whatever it is, the fresh air handling unit, it will decrease the temperature into 20 or 25. After that, that air handling unit supply the air to the Glycol. Then there is a primary coil is there. That is normal coil. Primary coil decrease the temperature up to 6 degrees Celsius air temperature, around 6 to 8, like this, mostly 6 And after that, that particular air will pass through the glycol coil. Then the temperature will come down to 0 degrees Celsius. And this temperature is going to the aircraft because that much chillness is required to cool down the aircraft very fastly. Because the aircraft, the ventilations are very small, and in the CFM is very small. In that situation, very cold is required. The design is like that for the aircraft. How is the welding of chilled water pipe tested? It's a very important question. There is two types of piping systems are there. The small piping system and the big piping system. For the small piping system, like for example, you are putting a 2 inches pipe, 3 inches pipe, directly you can put water and test it, no problem. But if it is a 6-inch pipe, 8-inch pipes, and its length is more than 50 meter, 100 meter, 200 meter, whatever it is, when you are filling the water, there is a leak found. Again, you need to drain the water. So that much volume of water you cannot handle. In that situation, what we are doing, first of all, there is two types of testing we are doing practically. The welding joints DP test, dye penetration testing. And the very important thing is that after dye penetration testing also sometimes leak may occur. There's a chances. Because, when we are commissioning the chilled water system, almost all the area sealing, false sealing is completed. That's the situation. In that situation, we are entering to the testing and commissioning. In such kind of situation, it's better to do with compressed air. That's what we was doing in our construction industry. DP test, of course, we will do for the big size of pipes. And there is a big size of compressors are there. Bring it or rent it and do the testing with the help of compressed air. And after the compressed air testing, it's okay. Normally it depends upon the consultant requirement. 12 bar, 10 bar, or sometimes it is 24 bar also we are doing the testing. It depends. And after that, of course, we need to fill the water and do the hydraulic pressure testing for 24 hours. Not 2 hours. 2 hours is only for a drama. We need to do the testing for 24 hours. That is safe. Even if you are an engineer, if your requirement is saying 2 hours, but go for 24 hours. Face any problem in the beginning, not at the end. That is very, very, very important in the construction industry. I think this video is getting more longer, so I will continue the system, the things in the next video. Keep tuned and subscribe my channel so that you will get such kind of informative video as soon as possible. Welcome. Thank you so much for watching. Bye-bye.